Good morning, everyone. Today we're going to be learning on graphing inequalities. So let's learn on how we graph simple inequalities. Okay, just a little review. So our goal is to graph and identify solutions for the given inequalities using the number line. Just a little review on the signs and symbols of inequalities. So if you have less than or greater than, our signs are like this. And if we're going to graph the inequalities with less than or greater sign than sign, we are dot, or we plot it with an open dot. And if we're going to graph an inequality with greater than or equal to or less than or equal to sign, or with a symbol like this, our inequality is closed. The dot where we are going to graph it, the point is closed. It means that that particular inequality is part of the solution. You will understand more when we have the example. Let's have the first example. X is greater than 6. So with this, we start at positive 6. It's right here. And it says that X should be greater than 6. So it should be greater than 6. So all the X's will be on the side. So we could just do the graph here. Alright, so it's also a simple way to look like X should be greater than 6, and then it go to 7, 8, 9, 10. So the possible solution for this inequality is we start with 7, 8, 9, and so on. You could go all the way to the end, like as long as many as you can to the positive side. Again, 6 is not a possible solution for this inequality because X must be greater than 6. Alright, let's look at the next example. In this example, it says X should be less than 2. So we go to 2, and then it says less than. So we go all the way to the side. Have you noticed the arrow? This arrow tells you where to go, actually. So the possible solution for this inequality, X, will be, it should be less than 2. So we start with 1, 0, -1, -2, and so on. So we could just start with 1. It could also be 0. It could also be -1. And you could even go all the way down to the left side. So that's going to be a possible solution for this inequality. Alright, example number 3. X should be greater or equal to -4. So I go to -4. And it says greater or equal to. So I had to close this -4. It's a closed dot or closed graph. And then it says it should be greater, right? So the greater to -4 is here. And you could go all the way down if you want to do your graph. And then a possible solution for this inequality, since it says X should be greater or equal to -4, so I would start with -4, -3, and -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as many as you can. But the first possible solution is -4, right, in terms of whole numbers. Alright, next question. Our next example is X will be less or equal to -3. So definitely we go to -3. And since it says less or equal to, we color it in. Okay? And then it says it should be less than -3. Less than -3 are here. Alright? You could make it straight. It's okay. I'm gonna make it straight. But then, if you also notice that the arrow is pointing that way, right? It goes that way. So it also gives you a clue where your arrow gonna go. As long as it's in standard form, X inequality number, X inequality number. I'll show you later on the other way around. So since here we're gonna say X is less than or equal to -3. So we start with -3. X is less than or equal to the -4. I'm reading myself because I said it wrong once. The -5, and so on. So these are the first 3 possible solutions for this inequality. Okay? All right, so what if the inequality is written not in a standard form? So it's the number first, inequality, and the variable. So how we do that? So we usually play safe by reading it and understanding what it means. So 3 should be less than x. So I'll go through 3 again. And since it's only less than, it's open. But then where are the arrow gonna go? So it says 3 should be less than the x. So it means 3 is less than the x, so the x gonna be bigger than 3. So there you go. So if it says x should be less than the 3 should be less than the x, so this is 3 and it should be less than all the x's over here. So therefore our possible solution gonna be 4, 5, 6, 7, 8, 9, 10, 11, 12, 1,000, 1 million. Okay, but let's check. Is 3 less than 4? Yes. Is 3 less than 5? Yes. Is 3 less than 1,000? Yes. So you need to read it properly before you plot them if it's not written in a standard form. Standard form means the variable first, inequality, and then the number. Okay, let's look at another example that looks like this. So here we go. It says 4 must be greater than x. So let's go to 4. It is open because it's just not equal to. And then it says 4 must be greater than x. So I couldn't get 5, I couldn't get 6, but that is not a possible x, right? 4 is greater than 5, no. 4 is greater than 6, no. So let's try this one. 4 is greater than 3, yes. 4 is greater than 2, yes. So we could say that our graph goes this way, because now we could see that 4 is greater than 3, 2, 1, and 0. So your possible solution gonna be, the first possible answer is 3. You cannot say 4, okay, because that's equals. And then 2, and then 1, and so on. So now you could say that the possible solution for this inequality is 3, 2, 1, 0, negative numbers, and so on. All right? Thank you, and I hope you learned something from today's lesson and review, and you could apply them later on when we solve one-step inequality. And if you have any question, you could always ask me. All right, have a nice day, guys. See you again next time. Bye.